Hi, my name is Ryan, and if you're thinking about designing your own healthy home, you're in the right place. Today I'm going to be talking to you about the heating and hot water generation in your new home. So firstly, what's the documentation you need to take consideration? The main ones are L1A and the Domestic Building Services Compliance Guide. L1A sets the minimum requirements for efficiencies on the main mechanical systems in your home. The Compliance Guide helps you meet these requirements and actually forms part of the building regulations. So, what fuel types can you use in a new home? There are many types. I'm going to go through the main headline ones. First to note is really that if you're putting a renewable in a new home, you can get an RHI payment, which stands for Renewable Heat Incentive. That's only applicable for anything that is considered a renewable or a low carbon technology. Please visit the Ofcom's website for the latest payments that you can get. So firstly, what are the types? There are gas, air source heat pumps, ground source heat pumps, electric and biomass. I'm going to quickly go through all of the 5 now. So gas, what are your options? Everyone's familiar with combi boilers. You've all lived in a house most likely that's had a gas combi boiler. Thing to note is to make sure it's sized correctly for your building. How you do that is depending on how many showers you intend to be used simultaneously. A wall mounted one could do about 1 or 2. A floor standing one could do about 2 or 3. In a floor standing, it has a small energy store, so once that's depleted, it goes back to only being able to produce a small amount of hot water relatively. On large homes, I would always recommend a hot water cylinder, anything above a 3 to 4 bedroom home, because the hot water cylinder can be sized to meet the hot water load. So gas combi boiler schematic, the combi boiler generates the hot water and also then generates heat for the heating systems. Typical sizes, not too dissimilar to what you've seen before. Combi boilers are pretty much the same size. Gas system boilers, so either it providing heat to the hot water cylinder or the underfloor heating or a radiator system. The only difference compared to a combi boiler is that you need to allow space for a hot water cylinder, which is typically around about 700 by 700, up to about 300 litres. So because the cylinder virtually extrudes upwards rather than outwards. So air source heat pumps, I'm not going to go too much into the technical aspects of an air source heat pump, but effectively it gets its heat from outside, brings it inside, and you then use it for your hot water and underfloor heating. It uses the refrigerant cycle, so it's a lot more efficient than just a normal electric radiator. For every sort of 1 unit of electricity you use, you get about 3 heating units out of it. There's lots more technical literature on the internet, so feel free to just Google that. The 2 main options are using it with a hot water cylinder or an energy store. So looking at the schematic, you have the external hot water cylinder, which is called a monoblock, which means that all the refrigerant is all contained within itself. You then distribute the heat via using water, either to a hot water cylinder or underfloor heating. Again, we would only recommend underfloor heating, not typical radiators. This is to do with the requirement of what temperature an air source heat pump can provide to the heating system. It's a lot lower temperature than what a normal gas boiler can produce. It can, in theory, provide it, but your efficiency will drop like a stone, so we wouldn't recommend it. The other solution is to use an energy store, which uses refrigerant pipe from the air source heat pump all the way back to the energy store, and then from that it generates the hot water and the heating pipe, the heating system's heat. Both the systems are pretty much the same size, but the external unit will change depending on the size of your building. The energy store system is generally limited to small installation, but please check with, there are lots of manufacturers that offer that sort of installation, but the more common one is the one on the left with a monoblock with a hot water cylinder. Most people are very used to installing that sort of system. So moving on to a ground source heat pump array. A ground source heat pump array can be either vertical, referred to as a borehole, or horizontal, which is inlaid in trenches. Borehole is pretty simple. You get a borehole rig, drill the holes, put the pipework in, and then get the energy from the ground. Trenches are pretty simple. Dig a 1 meter trench about 1.5 meters deep, lay the pipes, and then backfill it, and then you get the energy from the ground. Similar to an air source heat pump, but rather than the air, it's getting from the ground. One thing to note is that some companies will still recommend slinkies. A lot of companies and myself would not recommend a slinky system, just because there's a much higher chance that you take out too much energy from the ground. If it's not done correctly, you can freeze the ground, which means you take out too much energy and your system won't work that efficiently. Generally, some people might prefer slinkies if you've got a small site, but it is important to check that the array is properly sized. Here's a schematic similar to an air source heat pump system, except the heat pump is inside the building rather than outside, serving a radiator, underfloor heating system and a hot water cylinder. And then the typical sort of arrangement is you have the borehole leading to a manifold position, coming into the building, and then serving the heat pump, and then the hot water cylinder. So moving on to electric options, what are your first thing with electric? It is a very expensive and a very uncarbon friendly way of heating a building if not done correctly. If you are doing an eco home with a designer who can advise you on loads and how the building may work, there is a case in some instances that electricity might be useful. Predominantly most of the systems are similar to a gas boiler, except you replace it with electric. Why would you use it? Is if you had a very, very low heating load, like if you're doing a passive house. So some people argue that electric underfloor heating is better than putting a wet system in because it's a lot quicker to react, or it's cheaper to install. But overall, you've got to make sure it complies with your energy efficiency and carbon reductions. So please speak to your SAP assessor. And again, if you don't, it's a very expensive way of doing things. We talked about air source heat pumps. You get 3 units of heat for every 1 electrical unit. This only gets a 1-to-1. I know there are manufacturers on the market that suggest that electricity is 100% efficient, but what they don't tell you is that electricity is about 3 times the cost of gas. So you can spend a lot more money heating your home. And also the current grid is for electricity is quite high, so the carbon intensity is quite high on the grid. This will be dropping over the coming years, so making the case for electricity maybe in the future, but at the moment it's still best to use an air source heat pump or a ground source heat pump if you're thinking about using any form of electric rather than avoiding gas. With biomass, I haven't really gone through it into great detail because there are so many systems on there. You just need to make sure that the biggest problem with biomass is that you still have emissions in terms of NOx levels. So if you're bang in the city centre, it's probably not a suitable solution. You need to have fuel supplies to worry about making sure that you get the sustainable fuel supply. So you get either the fuels either in wood chips or in pellets. But this is a very expensive technology, and it only really is suitable for very large homes with estates. But then, depending on your personal preferences as well, if you've got a wood source nearby, and you might want to choose like a gasification boiler, which just burns logs into a heat store. But in any case, it's there are so many options. I couldn't really cover it in a video, so it's best to speak to a biomass manufacturer specialist. So solar hot water. So you can use solar hot water on any system that has a hot water cylinder. So I've given 2 examples, one with that's been built into the panels, and then another one is the solar hot water just plumbed onto the roof. What I've shown are 2 plate panels rather than evacuated tubes. Evacuated tubes are more efficient, but they are a bit more expensive. So more often than not, the flat panel units are becoming more and more popular, and also they just provide a slightly better look than evacuated tubes. So that's why they're becoming more and more popular. They also still have an RHI incentive as well, which is quite favourable for their system. Again, check the Ofcom website for their current tariffs. What options do you have for your heat emitters? Most likely you probably know that you've got underfloor heating or radiators. Underfloor heating is a very slow reacting system. Radiators are very quick to heat up a building. They provide sort of heat drafts, because the advantage with radiating underfloor heating is that the air temperature in the space is pretty much constant, and with the heat emitters there's always going to be some form of convection within the space compared to a radiant system. And the advantage is also, when they talk about radiant heating and underfloor heating being more efficient, what they actually really mean is you can actually have a lower internal temperature and you feel a lot more comfortable, and that's where the efficiency comes from. In terms of radiator types, there are three main radiator types. There's the traditional radiator, which we're all used to. There's the column radiators, which are very much at home in sort of Victorian old houses. They are quite nice column radiators. They are very large in terms of their water content, so that is not as quick reacting as a normal traditional radiator. And then there are a bit more aesthetically pleasing ones, like sort of flat panel ones that don't have the ribs, and a lot more, provide a little bit cleaner lines. So if you're doing a very high-end home, sometimes these type of radiators might be better, and you can actually get ones that have the pipes hidden behind the radiator itself. You just need to worry about how you control them. So with regards to towel rails, there are two types. That you want to have a towel rail in each of your bathroom or shower room. If you've got underfloor heating in there, you probably don't need a dual fuel towel rail. A dual fuel means that it's connected to your heating system, so it's heated during the summer via an electric motion heater plugged into it, or during the winter it's heated by your main heat source. If you've got a main heat source in the space, you will only really need it just for drying towels, so you can use that with electric switch. Pipe material, there's generally two options. There's copper or plastic. My preference would be copper, because generally it provides a better installation, but having said that, a lot of people do prefer plastic because it provides a quicker installation. Mainly this is probably the contractor trying to save money, both in material cost as well as installation. If it's done correctly, plastic is fine, but I'm always a bit dubious because plastic has an O-ring that you have to rely on for over years. I know the manufacturer does provide a sort of guarantee on this O-ring, and pretty much guarantees that it won't fail, but if it does fail, it'll be hard. Well, it's pretty easy to replace it, but it normally causes a problem. The advantage with copper is I would actually recommend a compression fitting type. So you use a tool to compress the pipe together, so it's just copper on copper with no hot works on site. System is still quite quick to install, but because it's slightly less forgiving in terms of you have to think through the routes and where pipes are going to go, it actually gets installed a little bit better than plastic, because more often plastic is just bunged in without being supported correctly. But if it is done correct, as I said at the beginning, if it is done correctly, then both systems are suitable for heating systems. Next I'm going to talk about is heating control. So smart heating control is becoming more popular now, internet enabled units as well. There are many types on the market, or you can just simply stick to a simple programmer. It is purely depending on how you want to run the building. If you're using a programmer, it can be very useful. If it's a simple system, pretty much future-proofing, because it's, well, obviously not out of date already, but it just isn't going to be classed as a gimmick, or you need to be changed over time. The other units, we're not sure about their longevity in terms of their sort of use, but I mean, everything is relatively future-proof. You just change the unit if you need to change it. But the advantage of an internet-based one is that you can operate your house remotely. I hope you found this video useful. If you have, please click subscribe If you'd like any further information, please leave a comment below or feel free to give us a ring or an email. Visit our website to get our contact details. Again, if you're going to build a home, please build a healthy home. Thank you.